So this was a structure pop quiz 1. So we'll go through. If any part you have doubt, you can mention. I will discuss that. Question 1, part A, 1, 2. Any doubt? No doubt. Explain A3. Explain the difference in the melting point of phosphorus and sulfur in terms of structure and the bonding. Why there is a difference in the melting point of the question is why there's a difference in the melting point of phosphorus and sulfur. We have to explain the difference in terms of the structure, like what is the structural difference. So first thing, in sulfur or in phosphorus, both are because both will be covalent structures, and both will be a simple molecular structure, simple covalent. This will also be a simple covalent. Phosphorus is having 15 electrons in one. Sulfur is having, in one molecule of a sulfur, it is having 16 electrons. And what will happen as the number of the electron increase, what kind of intermolecular force they will have? They will have dipole-induced dipole force. So both sulfur and phosphorus, they have a simple molecular structure and they have dipole-induced dipole forces. And the dipole-induced dipole forces increases as the number of electron increase. That's why sulfur is having a higher melting point than phosphorus. So both are molecular structure. And as both of them are molecular structure and these are the non-polar molecules. So what kind of intermolecular force it will have? It will have mainly dipole induced dipole force. And the force increase or dipole induced dipole attraction in sulfur is stronger than phosphorus. Why? Because sulfur has more electrons. So dipole induced dipole force increases as the number of electron increases. Nuclear charge, you cannot mention in term nuclear charge. And when you refer a intermolecular force, don't use the term nuclear charge for a simple compound, so covalent compounds. Sulfur is having more electrons. Sulfur is 16 and 32. And phosphorus is 15 and 31. So molecules of the sulfur contain more electrons as compared to molecule. And even the number of the atom in one molecule of phosphorus are usually 4, but in sulfur usually are 6 in one molecule. So overall, the number of electron also increases. Part B, 1, 2, 3, 4, any doubts? Part B, 1, 2, 3, 4, any doubts? No doubt. Part B5. Give 2 reasons why. Reason for the difference in the melting point of ice and ammonia. So why there's a difference in the melting point between the ice and the ammonia? The first thing, they both have the hydrogen bonds, okay? So in case of a ice, H2O, So it will have a hydrogen bond between the molecule. In case of ammonia, NH3, it will also have a hydrogen bond. Both of them hydrogen bond. But because oxygen is more electronegative, as we know, we move across the period, electronegativity increases. We have nitrogen, oxygen, fluorine. Fluorine is the most electronegative. So when we compare the hydrogen bond in fluorine, it is the strongest compared to oxygen and hydrogen, and it's stronger as compared to nitrogen and hydrogen. So what will happen? Oxygen is more electronegative than nitrogen. So the hydrogen bond which are formed between the hydrogen in ice are stronger than that of ammonia. That is one point. What about the second point? The second point, if you remember the reason, I mentioned that even though the hydrogen bond of a fluorine is stronger than oxygen, but the melting point of a water is higher than any of these two. Why the water is having a higher melting point than any of these two? Because the water has a tendency to form two hydrogen bonds per molecule. But all of them, like hydrogen with fluorine or nitrogen with hydrogen, these molecules only form one hydrogen bond per molecule. So in case of ammonia, we have only one hydrogen bond in one molecule. But in case of a water, we have two hydrogen bonds per molecule. So two reasons. One is oxygen is having a greater electronegativity, so the hydrogen bonds are stronger in water or ice, you can say. The second thing is in H2O molecules, it forms two hydrogen bonds per molecule as compared to NH3. Is it clear, this one, the reason? Question 2, part A1, any doubt? Let's sketching the graph for ionic radii. You just have to use the trend. In the graph, should I connect the points dot or should I make a best? No, because you have to predict. So try to draw a line of a best fit. You will not, instead of connecting dot to dot, in this case, because reason why we don't connect the dot to dot, like example, say nitrogen is here, oxygen is here, then fluorine is here. So we draw a line of a best fit. Magnesium is not there. So we'll try to draw a line of a best fit. Because in the question, we have to predict the magnesium. And it is mentioned in the question that you have to draw a line of a best fit. The reason why you have to draw a line of a best fit, because you have to predict the radius for, as it's there, then predict the radius of a magnesium using a straight line of a best fit. Then part 3, any doubt? Trend in ionic radii of a nitride to aluminium. In the third part, look, it's of 3 marks. So what are the points you should include? Number one, as we move across, like as you can see here, they all are isoelectronic. That's the first thing. Because if you see the ions, they all are isoelectronic. When we say isoelectronic, it means this has 10 electron, this has 10 electron, this has 10 electron, 10 electron, 10 electron, 10 electron, and 10 electron. So one mark is for mentioning a point that they all have the same number of electron, or you can use the term, they all are isoelectronic. That will be the first point. The second point, as we will compare the nuclear charge, like the difference. So in case the nuclear charge here for a nitrogen, it is 7, 8, 9, 10, 11, 12, 13. So aluminium, like as we move from nitrogen to aluminium, the nuclear charge is increasing. So if the nuclear charge increase, the attraction towards the nucleus, attraction of the nucleus towards the last or the valence shell electron will also increase. So as the attraction increase, the atomic size or the size of an atom will decrease. So generally, when we move from nitrogen to aluminium, the size of the ion will decrease. So 3 points, 1 mark for mentioning they all have same electrons or they are all isoelectronic struck ions. The second point, when we move from nitrogen to aluminium, the nuclear charge increases as atomic number increase. And the third point, that stronger attraction towards the nuclear from the nucleus towards the valence shell electron, which reduce the size of an atom. So when we move from nitride ion to aluminium ion, the size will decrease. The ionic radii will decrease. You can also mention that. Is it clear, this one? So nuclear charge increase, the nuclear attraction will also increases.